All right, continuing on with our discussion of the digestive system. So we left off with the stomach. We're going to continue to the small intestines. This is the body's major digestive organ. So we're primarily breaking material down and absorbing material through the small intestine. It's the longest portion of the alimentary canal, on average about 7 to 13 feet in a living person. It's called the small intestine because it's smaller in diameter. Than the large intestine. So in the image here, you can see the small intestine here is narrower than that. That's the large intestine there. It's a major site of nutrient absorption, and it extends from what we call the pyloric sphincter at the bottom of the stomach to the ileocecal valve, where it joins with the large intestine there. It's suspended, held in place from the posterior abdominal wall by things called mesentery. So we go to this next image here. So you can see small intestine kind of there. So this is kind of a cross, another view looking through small intestine here. You can see the mesenteries holding the small intestine in place there. All right. So throughout the alimentary canal, just to get a reminder, we have this thing called peristalsis, which is this rhythmic contraction to move material. So on the left here, we have peristalsis of the esophagus, but this whole process of kind of moving things through continues all the way throughout the small intestine and large intestine as well. The small intestine is divided into three segments called the duodenum, the jejunum, and the ileum. So the duodenum is this first part, and it's relatively short. The jejunum is the second part, and it's longer. It's kind of the middle length section. And then the ileum is the majority of the small intestine. So the duodenum, jejunum, and ileum. So when we begin breakdown in chemical digestion in the small intestine, this is primarily carried out through enzymes that come from intestinal cells and from the pancreas. They're carried to the duodenum, that very first part of the small intestine, through pancreatic ducts. In addition, we have bile, which is formed in the liver, and bile is good for breaking down lipid molecules like fats and oils and stuff like that. That enters the duodenum through something called the bile duct. And then the hepatopancreatic ampulla is the location where the main pancreatic duct and bile ducts join. And just a reminder, the ampulla is kind of this shape here. It's named after Roman ampulla, which were water or liquid vessels. It's kind of common throughout Roman history there. So here you can see the duodenum, that first part of the small intestine. So the pancreatic, this is a bile duct coming down. This is the pancreas coming down over here. So the gallbladder would go into the bile duct over there. And then this region right here is the hepatopancreatic ampulla, which is where that pancreas and the bile duct join together. And then there's a sphincter with a little ring of muscle to kind of hold everything in place to allow that to secrete whatever it needs to secrete into the duodenum as things are kind of continuing on. And then it would continue past and then go into the jejunum there. So major functions, modifications of the small intestine to increase absorption, we increase surface area. And then decrease in number towards the end of the small intestine. We find these things kind of scattered throughout. We have these things called villi, which are these small little finger-like projections. They have a capillary bed, microvilli, which are tiny projections of the plasma membrane on the surface of the villi, and then kind of you have these major circular folds, which are composed of both the mucosa and the submucosa. So we'll look at an image of that as well. In addition, we've got Peyer's patches, which are collections of lymphoid tissue. They're located in the submucosa. They increase towards the end of the small intestine. And then more are needed there because food residue contains much more bacteria by the time it gets there. So you can see these Peyer patches just kind of scattered throughout the small intestine there. All right, so here we are looking at it. So here you can see these big folds, the circular folds. You can see kind of these little finger-like projections all over, and those are the villi. And then if we go one more layer deep on the surface of the villi, you're going to have these little microvilli to stick up on the top. So we're going to go in order our circular folds, right? Then we have the villi on the top. And here's where you can see that those capillary beds kind of running around a lymphatic vessel there. So anything that's going to go into the bloodstream is going to come through. Those are simple columnar cells, so anything's going to come into there. We're going to pick it up in our capillaries and then carry it into our veins where it can then get carried off. Ultimately, it goes to the liver to be kind of processed there. But we also have that lymphatic system there to kind of check to make sure that we don't get anything in our bloodstream that we really don't want to have in our bloodstream at that point. And then on the very, very surface of it, right, this is where the actual kind of interface between the lumen of the intestine and the cells are, is across these microvilli, known as the brush border on the surface of the cells there. Okay. Next, we have the large intestine. This is larger in diameter but shorter in length, about 1.5 meters. That's about 4 or 5 feet or so. It extends from the ileocecal valve to the anus, and then it's composed of these different regions. So we'll look at the cecum, the appendix, the colon, the rectum, and the anal canal as well. So the cecum is the sac-like first part of the large intestine. It contains the appendix, which hangs off of the cecum. The appendix is associated with lymphoid tissue. It sometimes becomes inflamed as appendicitis. And then the colon is composed of four different parts. The ascending, which goes up the right side of the abdomen. The transverse, which travels across the abdominal cavity. The descending, which goes down the left side. And then the sigmoid, which is kind of this F-shaped region, which goes into the pelvis. So the sigmoid, colon, rectum, and anal canal are all located within the pelvis. And the rectum itself serves as a site of temporary fecal storage there. Things that we find in the large intestine are these goblet cells. They produce alkaline mucus to lubricate the passage of feces as it goes through there. The muscularis external layer is reduced to 3 bands of muscles, and they cause the walls to pucker into these little pocket-like sacs. And in some people, those can actually develop as they age into these kind of big pockets that they have to go into, and they'll do like abdominal surgery to kind of clear that out because those can get infected as well. So here we're looking at the cecum. This is where we're going into the ileocecal valve. This is coming in from the small intestine here. And we do have layers of mesentery tissue kind of holding everything in place there as well. So from the ileocecal valve into the large intestine, here's the appendix that hangs off of here. So this is ascending, colon, transverse colon, descending colon, sigmoid colon, and here's a haustrum, these little pockets that kind of hang off the side. And they can, like I said, they're the ones that can become kind of closed off and infected if people need it. And then we get down into the rectum and then the anal canal. Then we'll get into kind of the layers of muscles that kind of hold everything in place there. So the anal canal is the anus. It's the end of the opening of the large intestine. So there's a couple layers of muscles. Ones that we have what's called the external anal sphincter. So there's skeletal muscles, and this is voluntary. And then inside of that, and we have what's called the internal anal sphincters, and these are smooth muscles, and they are involuntary. They normally close, except when we kind of choose to defecate. The internal anal sphincters respond to pressure, so as the feces builds up inside the rectum, then those internal anal sphincter muscles want to relax and let the feces go through. But we have conscious control of the external anal sphincter, so we can be like, oh, I'm not going to poop right now. But then, like, as you decide, like, okay, now's the time I'm actually going to go ahead and defecate, you can open those up. And if those are already open, then the feces can come through. And then we carry indigestible food residue to the body's exterior through the feces there. All right, so here you can kind of see the rectum. Here's those internal anal sphincter muscles. Here's the external anal sphincter muscles. And then we have a lot of kind of blood vessels that are around there called hemorrhoidal veins. So if you hear somebody having a hemorrhoid flare-up, those veins can become inflamed and enlarged, and it can be very painful. So we want to, and then sometimes they have to go in and do surgery to kind of cut those out or burn them out so that the person's not in any pain or in risk of infection from bacteria in there. All right, and we'll move on. Right, and that gets us to the end of that part. So go ahead and take a stretch break, and we'll continue on in just a little bit.